Hey everybody, Mr. Judson here. So we have 2 days left to review, today and then also tomorrow. And then our exam will be on Tuesday next week. So I will be sending out an email to you guys where I need for you to have a conversation with your parents about when is the better time for you to take the test, either 10 o'clock in the morning or 6 o'clock in the evening on Tuesday. Very important that your parents are there. Some of you have already heard me say this. When we did our retakes earlier, I would get emails from parents saying, oh yeah, I would have returned this to you sooner, but I was at work and my son was waiting for me to come home and sign the test. Well, to me that says your parent wasn't there. They were at work while you were taking the test. That's not the deal here. And when we sign at the bottom saying that we are following the rules and practicing academic honesty and integrity, that's what we're saying, is that we've got someone there to monitor ourselves. Okay? And so I will remind parents of that as well in the directions when I send that test out. All right, so we reviewed over Chapter 5 yesterday, so today we're taking a look at Chapter 6, and kind of the same thing. We'll just do some practice questions, give you guys a review assignment, and we'll do the same thing tomorrow as well. All right, so let me get you guys a problem here. So in Chapter 6, we learned about law of sines and law of cosines, and that you can use those in triangles that are not right triangles. And so the question here is they want us to find x. And you may look at this and think to yourself, oh geez, I don't know how to find x right now. I don't have enough information. Well, if that's the case, then go get that information. You got to figure that out. And I always tell people, if you're not sure what to do, just find anything. Find any piece of information. And then continue to do that, find another piece until you get, what it is you're looking for. So you guys go ahead and try this. Alright, so I'd probably call this A, B, C. And so we're trying to find angle B. But I don't have the side opposite that yet. So I can't really go straight to law of sines. I could find this angle, angle A, and once I know that, I could just subtract these two from 180, and then I would have what I'm looking for. So that's my plan. So I'm going to say that the sine of 50 degrees over 11 is equal to the sine of angle A over 15. Now the only thing I'm a little bit cautious of here is angle A is the largest, well, it's larger than this one right here. So if there is an obtuse angle, that could be it. But really, I don't know what else I could do right here. Okay? Let me just kind of show you why that could happen. If I have a side right here that is AC, and this side is 15, and this is an angle of 50 degrees, I don't really know. See, it doesn't tell us what the length of this side is. So I don't know if this side really comes down like this, or does it come down like this? See, I could just have a really bad picture here. Some people might say, well, no, it's definitely this one, Judson, just look at the picture. But I don't know if I drew the picture right. Right? So there's really two different answers that would work for this. As far as the Central Washington test goes, they're not going to be picky about this right here. They just want us to find an answer. So what we're saying here really is okay. All right? But in reality, there is a bit of a question here. That's why law of sines isn't always perfect. All right. So let's see. If I want to get sine of A by itself, I'll bring this 15 over to the other side. Here I'm dividing by 15, so over here I have to multiply. And now I just want to figure out what that's equal to. And so I've got 15 sine 50 divided by 11, and I got 1.045 equals the sine of angle A, and I'm already spotting a problem here. This number can't be larger than 1, right? Sine and cosine can never be larger than 1 or less than -1. So when I do inverse sine, I'm going to get an error message on the calculator. So what does that mean? Let me go back to the picture that I just drew here a second ago. Here's the side AC. Here's the side 15. This is 50 degrees. And I've got this other side that is 11 that can either go here or over here somewhere. Well, what happens is that side of length 11 doesn't even reach the segment AC. If I swing this segment this direction or this direction, I'm never going to get this endpoint to touch point A or somewhere over here. And that's why I got an error message. So there is no solution to this problem. And that happens sometimes. All right, let's try another one. All right, so here's a problem that we have never done, so it's going to make you think a little bit. But we do have enough information to do this. It says to find the angle between the two vectors, u, which is in component form 5, -2, and vector v, which in component form is 4, 7. Remember, component form means it starts at the origin and goes to this point. You guys see if you can do that. Alright, so first thing I'm going to do is I'm just going to sketch these two vectors. So vector u starts at the origin and goes to the point 5, -2. Here's 5, -2. And vector v starts at the origin and goes to the point 4, 7. So 4, 7, it's actually going to be a little bit higher than that. But there it is. So this is 5, -2. And this is 4, 7. This, of course, is the origin. And we're trying to find this angle right here. So how would I do that? Well, if I go ahead and just draw a segment like that, I have a triangle. And if I know the length of these three sides, I should be able to find that angle. Right? If I know all three sides, I could use law of cosines to find an angle in the triangle. So I'm going to have to do the distance formula to figure out each of these, which the distance formula is just the square root of, doesn't matter which point is point 1 and which is point 2. I want to do x2 minus x1, so 5 minus 4, that's 1. Square it, you get 1. -2 minus 7, that's a -9. Square that, you get 81. So this is the square root of 82, this side right here. And then if I find the length of this, we know that the magnitude of a vector is just the square root of x squared plus y squared. And that's because when I subtract off point 1, I've got zeros here. So this will be the square root of 25 plus 4, which is the square root of 29. And this one up here will be the square root of 16 plus 49. Which you add those together, you would get 65. Square root of 65. And so what I'm going to do now is I'm going to call this I'll just call this side A, this is side B, this is side C. And so from the law of cosines, B is the side that's opposite angle theta. That's what I'm looking for. So I know that B squared equals the other two sides squared and added together minus twice the product of those two sides times the cosine of the angle that's opposite B, which we'll call theta. So these formulas you would want to have written on your sheet of notes. Remember, you get an 8.5 by 11 sheet of paper, one side only. The goal is to be able to just write a little bit larger so you don't have to make it tiny like you would on a note card. Okay? Alright, so I'll plug in my numbers. The square root of 82 squared is 82. A squared would be just 65. C squared would be 29. Minus 2 times the square root of 65 times the square root of 29 times the cosine of theta. So first thing I'm going to do is move these two numbers to the other side and subtract them. So I'm going to do 82 minus 65 minus 29. And so what I've got here is a negative 12 is equal to, I'll just write all this stuff down, a negative 2 root 65 root 29 cosine of theta. And so now I want to move all this stuff over to the other side and divide. Since I'm going to do a negative divided by a negative, that'll be positive. So I've got 12 over 2 root 65 root 29 equals cosine theta. And so I just need to figure out what this is equal to. Remember, when you do this on your calculator, you have to put all this stuff in parentheses. Because otherwise it just does 12 divided by 2, which is 6, and then times these two things. You'll get a number larger than 1. Alright, so I've got 12 divided by, in parentheses, 2 root 65, arrow out of that, times root 29, I'll arrow out of that, and then put another parenthesis to close off the denominator. And so what I got here is 0.138 equals cosine theta. I'll do the inverse cosine of my last answer. And I got 82.057 degrees. There's the angle between those two vectors. So what I like about this problem is, it makes us think a little bit as opposed to just, here's a problem, just crank out a formula. That's really what Central Washington is about. They want us to be able to take the things that we've learned and apply them to maybe something that we haven't done before. Think our way through that. All right, let's try another one. All right, so again, my ink is bleeding here. So I've got a triangle. This side is 17, this side is 20, this side up here is 14. And what they want us to do is they want us to find the middle-sized angle. All right, so the largest angle should be opposite the largest side. So this angle up here is our largest angle. The smallest angle should be opposite the smallest side. And so the middle size angle should be opposite the middle side. So that means we're looking for this one right here. And since I do not know an angle on its opposite side, this looks like law of cosines again. So I want the side opposite this angle, which is 17. That's what I'm going to start with. 17 squared equals the other two sides squared and added together, minus twice these two sides, times the cosine of angle x. So I'm going to take my calculator and I'm just going to do 17 squared minus 20 squared minus 14 squared. Minus 20 squared minus 14 squared. And what I got was a negative 307 equals, when I multiply this, I would get, let's see, 2 times this would be 28. 28 times 2 would be 56 with a 0. So a negative 560 cosine x. So now I'll bring this over to the other side and divide. I'm doing a negative divided by negative, that's positive. I'll just write this down as a fraction. And so now I need to do the inverse cosine of that fraction. So second cosine of 307 divided by 560. And I got x equals 56.755 degrees. I think our directions on the test will say always round to 3 digits, unless it says otherwise. So that's going to be still our most common thing. All right, let's try another one. All right, so let's see. I've got a ship that leaves port with a bearing of north 62 degrees east and does 24 knots, so it's 24 nautical miles per hour. 3 hours later, it changes course to south 80 degrees east and travels for 2 more hours. How far is the ship from port and at what bearing? You guys see if you can figure that out. All right, so my boat leaves port and it travels with a bearing of north 62 degrees east. So if I start facing north and rotate, about 2/3 of the way, I would have something like this. Okay, where this angle was 62 degrees. It went for 3 hours, so 3 times 24, that would be 72 nautical miles. And then at this point, it changed course. So let me put another compass right here to south 80 degrees east. So it's now going this direction. This is 80 degrees right here. And it did that for 2 more hours. So 2 times 24 would be 48 nautical miles. And so our question that we're trying to answer is, how far is that ship? We'll call this point S for ship. I'll just write it out. So I'm trying to figure out this distance and at what bearing. So I'm assuming that the ship is above this east-west line. I don't really know that for sure. I mean, that's just an assumption. I may be right, I may be wrong. We'll find out. And the bearing is going to be this angle right here. Again, that's an assumption because I don't really know where this line is supposed to be, but I have to find this angle. So what I'm going to do is I'm going to find the angle inside the triangle, and if 62 plus that angle adds up to more than 90, well then I know I should have drawn it down here. Okay? And I'll deal with that when it happens. Alright, so now I need to start putting some information into my picture here. So there's a lot of different ways to figure this out, but to me it seems like the easiest way is if I extend this east-west line all the way over, it's going to form a right angle right here. And so these two angles in this triangle have to add up to 90. So 90 minus 62, that'd be 28. And then I'd do this 90 minus 28, and I would get 62 degrees right there. Now somebody else might have just looked at this and said, north-south lines are parallel, and so these two angles right here are alternate interior. So they should be equal to each other. So I now know that this whole angle here is 142. And that happens to be the angle opposite the side that I'm looking for. So I could now use law of cosines and say this side squared equals the other two sides squared and added together minus twice the product of those two sides, 72 times 48, times the cosine of the angle that's opposite this side, which is 142 degrees. And so when you look at that, we've already got x by itself. I just need to figure out what this is equal to and then take the square root. So I've got 72 squared plus 48 squared minus 2 times 72 times 48 times the cosine of 142. And so I got x squared equals 12,934.730. So now I'll take the square root of that. So square root of my last answer. And I got 113.731 nautical miles. All right, so I now know that this right here is 113.731. So now I need to find this angle right here. I'll just call this angle alpha. And remember, if it's larger than 28 degrees, that means this line should have been down below the x-axis or the east-west line. If it's less than 28, then I drew my picture correctly. And I really don't know which one it is. But since I know an angle and its opposite side, I'm going to go ahead and use law of sines. So I'm going to start by saying sine of alpha over 48 is equal to the sine of 142 over 113.731. And so what I want to do to get sine of alpha by itself is I want to get rid of this 48. So I'll move it to the other side and multiply. And so what I have now is 48 sine 142 divided by my last answer. And so I got sine of alpha equals 0.260. It's not an angle until I do the inverse sine of it. So alpha is going to equal second sine of last answer. I got 15.061 degrees. So it is less than 28, so my picture was correct. Again, I didn't know that ahead of time. There's really nothing I could have done to know it until I got to this point right here. So if I add that 15.061 degrees, this angle right here, to the 62 degrees, then I would have my bearing. So that's going to be 77.061 degrees. North, 77.061 degrees east. So there's my distance, there's my bearing. And the last thing I would do is try and write that as a nice clear answer. I'm actually not going to do it. This probably sounds cheesy, but this red pen is running out of ink. I need to make it last one more day, so I'm going to try and save the ink. I don't have any more red refills here at home. All right, so this problem actually could have been done with vectors, and so we'll do something similar to it tomorrow and take a look at how this could have been a vector problem. You might be able to kind of see, the ship was going this way, then it was going this way, so the two vectors are head to tail. If I could just get both of those into component form, then I would be able to answer this. So I'll save this problem, and we'll do it tomorrow in vector form. And To me, I think vector form is probably easier, although there's one key thing that if you don't catch it, it would mess you up on this. Okay, but I'll save this problem for tomorrow. All right, that's it. That's all I have. Really, my main goal for today is to get you guys to practice law of sines and law of cosines. And so let me get you some homework. All right, so second to the last assignment, number C23, page 482. We're going to do 10, 18, 19, 21, 31, and 32. Hey, keep on plugging in, you guys. I know we're getting to that point where it's like everybody just wants to be done. This online thing has been difficult, but we got a test coming up on Tuesday. Let's make sure we walk away from that test feeling good about our efforts. It's not a good feeling to sit down to take a test and look at questions and just go, oh my gosh, I don't even know how to do this. And you get a lot of frustration, and yeah, we want to walk away with a good feeling because we put in the time and the effort, and it paid off in the end with a good score on this exam. Just to be clear, this is not an exam you can say, oh, I don't want to count that. Just don't count it, Judson. No, it counts. We're fighting for our Central Washington grade right now, and this test definitely counts. We want to do well. It's our college grade, and I really hope that people aren't just going, oh, we've got a, this sort of safety net that you can take an emergency pass or an emergency fail. But again, you want to walk away feeling good, not feeling bad. And I think it's important. You want to do well at it, okay? All right, there it is. One more day tomorrow, and then we just have our exam. So, see you guys tomorrow. Take care, be safe.